right, so the next lesson for our 3D solids unit is going to be surface area of pyramids. So that's what we're going to focus on today. Now, before we get to that, one of the things that we're going to encounter when we're dealing with our pyramids is we're going to have these different shaped bases that we haven't dealt with before. Now, if you think back to when we were working with the prisms, we would have like a triangular base, and we would be able to find the area of that using base times height divided by 2. Well, we're going to encounter some other shapes like pentagons, hexagons, that are regular shapes, meaning all the sides are the same value, and we need to know how to find the area of that shape. Now, in this case, whenever we have something like that, we're going to use this formula here, where area equals the apothem times the perimeter of the base divided by 2. Now, the new piece here is the apothem, all right? And that's what I'm going to start with today's lesson. I'm going to teach you how to use the apothem and what it is. So what the apothem actually is if we take the center of our shape, and remember it's a regular shape, so that means all the sides are congruent, and we draw a straight line forming a 90-degree angle with that side, this is called the apothem. The radius of a shape goes from the center to a vertex. All right, so we were going to the middle of a side with the apothem, and the radius goes to a vertex. So I'm going to show you how we're going to use that. All right, so here we have a regular shape, and again, these will only be dealing with regular polygons like this. That's the only case we're going to look at. Now, we have a regular shape here, meaning all the sides here are 24 units. So what we want to do is we want to first draw in the apothem. All right, so from the center to the middle of that side, or any of the sides, forming a right angle. And then I'm going to draw in my radius, so from the center to any vertex. So in this case, we're going to look at this shape. What you should hopefully recognize is now we're looking at a right triangle. Now, if we take this side and we're cutting it in half, we're drawing this apothem from the center to the middle of one of these sides, we're going to be cutting this side value in half. So this side is now 12 units. All right, so what I'm redrawing is this piece right here. Okay, those match up. So now we have to have some angle measures to be able to figure this out. If we look at the center here, we want to find this angle right here. So what we're going to do is we're going to imagine how many of these triangles we could draw in. All right, so let's say I had one here, I could draw here, here. So for each side, we're able to draw in 2 of the triangles. All right, and you don't need to do this every time. I'm just trying to show you where I'm coming from here. All right, so we have on each side 2 triangles. So I know I have 6 sides with each side having 2 triangles. So I know I have a total of 12 of these triangles in this shape. Now how that's going to be helpful is finding this degree measure, that angle measure we're looking for. So we're going to take 360 divided by 12, and that's going to give us this angle right here. So that will give us 30. Now, what you might hopefully recognize is that this is now a 30, 60, 90 triangle. So what we're going to be looking to solve here is the apothem. All right, so I'm going to call this X. So we're looking for the long leg. We have the short leg. We have the 12 that's directly across from that 30. We need the long leg directly across from the 60. So if you remember, to find that, we're going to take 12, and we're going to multiply that by the square root of 3. All right, so this is our apothem. And what I'm actually going to have you end up doing is actually multiplying that out to get a decimal to work with. So this will round about to 20.8. All right, so there's our apothem. Now, what we're actually trying to do is find the area of this polygon. So to do that, we're going to take the apothem. So I'm going to do my area of my base. All right, keep that notation consistent. So I have 20.8 times my perimeter. So I have 24 times 6 sides, which will give me 144. Okay. Divided by 2. So that will give me an area of this base being 1,497.6. So this is a piece that we will be using in our formula to find these different areas that we'll be talking about later in the lesson. So let's try one more example, again with a hexagon. So we have a 6-sided shape. We know each of the sides is going to be 10, so I'm going to start by drawing in the center and the apothem and a radius. So I'm going to recreate this triangle here, right, where this is my apothem. And then since the whole side is 10, when we cut it in half, we're going to have that side be 5. All right, and again, because we could draw in 12 triangles here, because we have 6 sides and each side holds 2 triangles like this, we're going to take the 360 divided by 12 to get 30 degrees. And that comes from, think about this center as like a circle. All right, we're dividing that by those 12 triangles. That means we have a 30-degree angle here, leaving us with a 60-degree angle there. Again, a 30, 60, 90. We know that the short side is 5, so we're going to try to get the long leg by multiplying that by root 3. So 5 root 3, and we're going to multiply that out to get about 8.7 as our apothem. All right, and again, we're using this to find the area of this shape. So to do that, we take the apothem, so 8.7, times the perimeter, so 10 times 6, give us 60, divided by 2. And that would leave us with an area of 261. All right, so on this page here, we have some vocabulary. A few things I do want to note right now, that we will still have things that are oblique, so they're slanted. But the new piece here is the slant height. So this is going to be specific to what we're going to start talking about today, and that will be represented by a lowercase cursive L. All right, so that will represent the slant height. So if you look at these pictures here, so like I said, we're going to have different kind of situations, different sizes, different shapes. So if you look here at our pyramid, you can see that there's a dotted line coming from the vertex down to the bottom of one of the sides of the base, and that's the slant height. So think of it, if you're standing at the vertex on this shape and you slid down to the bottom, to the ground, that side, that line that you slid down, that's the slant height. All right, so that's what we're going to represent as that lowercase cursive L. All right, and here is our formula. So to find the lateral area, we're going to take the perimeter of the base multiplied by the slant height divided by 2. All right, you'll see it right here represented with the 1/2 out front, but again, this means the same thing. All right, and again, this lowercase cursive L means slant height. So we're going to take a look at this square pyramid. Now, since we know it's a square pyramid, we know the base is a square and all 4 sides are the same. So we're able to find our perimeter by doing 4 times 4. And we know that's going to give us a perimeter of 16. Our slant height is this line from the vertex to the base, all right, sliding along that face there. And that's a value of 6. So to find our lateral area, we're going to take 16 times 6 divided by 2. All right, and that will give us 48. All right, let's look at this next example. So again, we want to find the lateral area of this square pyramid. So again, our lateral area formula is the perimeter times the slant height divided by 2. So our perimeter, since we have a square pyramid, we know each of the sides is 2.5. So I'm going to take that 2.5, multiply it by 4. All right, and that will give me a perimeter of 10. And then my slant height from the vertex here to the base of the side is going to be 5. So we're going to plug this into our formula for our lateral area. We have our perimeter of 10 times our slant height of 5. I'm going to divide that by 2, and that will give us a lateral area of 25. All right, so now we're going to look at this hexagonal pyramid. Same idea, we still have our formula as lateral area equals the perimeter times the slant height divided by 2. Now again, whenever you have a base like this, it'll always be a regular shape. So that means that all the sides are congruent. So to find our perimeter, we're going to take 8 times 6. That'll give us our 48. Right? And then our slant height is 20. So our lateral area is 48 times 20 divided by 2. And that'll give us 480. So now we're going to start to talk about the surface area of these pyramids. When we talked about the surface area with our prisms, we had our lateral area formula plus 2 times the area of the base. Now that was because we had 2 bases that we were adding on the value for. However, here, like I mentioned in class the other day, we're going to only be adding 1 area of the base because we only have 1 base. So the lateral area was taking into account all the faces, so all around the outside, and not that base. So we're now going to add on the area of the base as well. So our surface area formula is the perimeter times the slant height divided by 2 plus the area of the base. And again, where this part right here is our lateral area. All right, so this problem here has a few different things going on. So remember, for our surface area here, we need our perimeter, our slant height divided by 2 plus the area of the base. So we need a perimeter, a slant height, and the area of the base. Now, a few things. We see that this is a square pyramid, so that means all the sides are going to be the same in this square. Now, I see that these side values are labeled as 8. So I know my perimeter is going to be 8 times 4. So that'll give me 32 as my perimeter. My slant height I'll come back to in a second. And my base, the area of my square, is going to just be 8 times 8. And that will give me 64. All right, now I'm going to come back to the slant height. So what I want you to recognize is that we have this line dropping from the vertex down to the center of our square, our base. And then we have the apothem coming out from that to the middle of one of our sides. And then attached to those is the slant height. Now what you see here is that we have this right angle. So we have a right triangle here. So we're solving for the hypotenuse, which is our slant height. So we have that straight up and down as 6. The across from the center to the side of our base is 4. So we need to use that to solve for our slant height. So we're going to do 4 squared plus 6 squared equals L squared, or our slant height squared. So I'm going to get 16 plus 36. I'm going to add those together, so I get 52. And I'm going to take the square root of both sides. So our slant height is roughly 7.2. All right, so that's 7.2. So now we have all the information we need to plug this in to get our lateral and surface area. So like we did before, I'm going to find our surface area, and then I can pull my lateral area out of that after. All right, so I have my perimeter of 32 times my slant height of 7.2 divided by 2 plus the 64, which is the area of the base. So 32 times 7.2 divided by 2 will give me 115.2 plus 64. All right, so already right here we know our lateral area is 115.2. All right, and then I'm going to add that 64 in, so I get 179.2. So that's my surface area, and my lateral area again is just this first part here, which gives us the 115.2. All right, so let's look at this square pyramid, and let's find the surface area here. So we need our perimeter, and again, it's a square pyramid, so we know all the sides are congruent. So all the sides are 10, so I'd have 10 times my 4 sides of my square would give me 40. My slant height, which is given to me, is 13. And then my area of my base, for my square, it's length times width, or 10 times 10, which will give me 100. All right, so I have 40 times 13 divided by 2 plus 100. So 40 times 13 divided by 2, we're going to get 260 plus 100. So my surface area is 360, and then my lateral area is 260, right? This part right here. All right, so here we're going to be finding the surface area of this regular pyramid. Now again, regular means all the sides are the same value. So what we have to do in order to find the base for this, the area of the base, we need to find the apothem so that we can use the formula apothem times perimeter divided by 2. And again, this gives us the area of the base. All right, so I'm going to start, I know again my surface area is my perimeter times my slant height divided by 2 plus the area of the base. All right, I'm going to write down over here what I have. I have my perimeter is 5 times 1, 2, 3, 4, 5, 6 sides. So 5 times 6, give me a perimeter of 30. My slant height is 8. And now we need to figure out the area of the base. So to do that, we're going to have to find the apothem. Now, what's drawn right here is just a picture of that base, how I've depicted it before. So each of the sides is 5. So when we draw the apothem in, that forms a right angle and cuts the side in half. So we have 2.5 is from here to here. All right, we also know that this is a 30-degree angle because we can form 12 of these triangles. So we can take the 360 divided by 12, which will give us that 30-degree angle. All right, so we have 30, 60, 90, and so this is 2.5. We need to find the apothem here. So we're going to take 2.5 times the square root of 3, and let's calculate what that gives us. All right, that'll give us about 4.3. So to find the area of our base here, we do 4.3, so that's our apothem, times the perimeter, which we've already found is 30, divided by 2. All right, so we get 4.3 times 30, which is 129, divided by 2 is 64.5. All right, so now I have all my information to plug this in to our formula here. So I have 30 times my slant height of 8 divided by 2 plus 64.5. So 30 times 8 divided by 2, so that'll give me 120 plus 64.5. So my surface area is 184.5, and then my lateral area is 120. All right, I know the confusing piece here is going to be dealing with these apothems. I promise you, the more you work with them, the more familiar you're going to get with them. It is a weird concept, but just know the apothem, this process, helps you find the area of the base. All right, let's look at one more. And right here we have a regular pyramid. So again, that means the base, all the sides are the same. We need to find the surface area. So to do that, we need our perimeter times our slant height divided by 2 plus the area of the base. So our perimeter is 6 times 3 because we have each side is 6 and we have 3 sides on our base, so we have 18. Slant height is 8. Now we need to find the area of the base, which is our base times height divided by 2, because remember we're talking about a triangular base here. Now when we do that, let's look at this. We know we have a regular triangle. So that means that all the sides are the same. Now remember, we called this an equilateral triangle. Now if it's equilateral, we also know it's equiangular, and all of the angles are 60 degrees. So if we want to find the height of the triangle, we need to cut this in half, have this side drop down, this line drop down and form a right angle. And that would be our height of this triangle. Now if we do that, we're going to be looking at one of these triangles as a right triangle. So I'm going to redraw this. All right, so we have that right triangle, we have the 60. Now this angle here, we cut in half when we drew in this height. So that would make that angle 30. All right, again, we took this side, we drew in the height, we cut it in half. So that would make each of these sides 3, each of these pieces 3. We still have this hypotenuse, this side being 6. And what we're solving for is this height, all right, this x value. So the reason I'm doing this again is because we have the base, we need the height in order to find the area of this triangle. So we're going to take, again, we have a 30, 60, 90. We have the short leg, we need the long leg. We're going to take 3, multiply by root 3. All right, and that's going to give us about 5.2, which is the height of our triangle, of our base. All right, so to find the area, we take our base, which is 6, times our height of 5.2, and divided by 2. And let's see, 6 times 5.2 divided by 2, so we get 15.6. All right, and lastly, to get my surface area, I'm just going to plug it all in. All right, so I have 18 times 8. It's 144 divided by 2 is going to give me 72 plus 15.6. All right. So I'll have a surface area of 87.6 and a lateral area of 72.